Hello everyone. Today's video will explain the working principle of a transformer. A transformer is a passive electrical device that transfers voltage from one circuit to another through the process of electromagnetic induction. It is mainly used for stepping up or stepping down the voltage between circuits, known as a step-up or step-down transformer. The main component of a transformer is the core, which is the central part of the transformer. The core is made of iron, silicon steel, or ferromagnetic material, and is made up of laminated plates of thin metal sheets with insulation coating or paper. The core of a three-phase transformer consists of 3 frames located on the same plane, each frame having a low-voltage winding and a high-voltage winding. The core provides a magnetic flux path around it. The primary winding, also known as the coil, generates continuously changing and alternating flux when supplied with AC power. If a secondary winding is placed near the first winding, a portion of these alternating fluxes will link with the second winding. As this flux continuously changes, both in magnitude and direction, the changing flux must be linked to the secondary winding. According to Faraday's law of electromagnetic induction, an induced electromotive force, EMF, will be produced in the secondary winding. If a circuit is closed on the secondary winding, current will flow through it, which is the basic working principle of a transformer. According to Faraday's law of electromagnetic induction, an induced electromotive force, EMF, will be produced in the secondary winding. The winding that receives power from the source is called the primary winding. The winding that produces the required output voltage due to mutual induction is usually referred to as the secondary winding. If the number of turns in the secondary winding is greater than the number of turns in the primary winding, it is called a step-up transformer, meaning it increases the voltage between the primary and secondary winding. Conversely, a transformer that decreases the voltage between the primary and secondary windings is called a step-down transformer. Each AC current flowing through the primary winding generates a changing magnetic field that surrounds the winding. This field, in turn, passes through the transformer core and connects with the secondary winding. This induced EMF is defined by the mutual induction and insulation is required between the primary and secondary windings to prevent short circuits. Finally, transformer oil is used internally in the transformer to prevent various energy losses such as eddy current losses, hysteresis losses, and copper losses. Transformer oil is an excellent thermal conductor that effectively reduces the temperature of the copper coils, preventing them from burning out. Radiators on the transformer help to accelerate the cooling rate, thus improving the load capacity of the electrical transformer. Buchholz relays are used to detect any faults within the transformer. I hope you understand the working principle of a transformer.